Hey ICP, welcome to today's class. As always, we're going to review what we know first, and then we're going to learn some new stuff about the periodic table. So let's go ahead and try number one together step by step. First, try part A. How many electrons does carbon have if it has 6 protons and 6 neutrons? The logical way to do this is to say that protons are positive, it has 6 positive protons, and it needs a neutral charge. So it must have 6 negative electrons to cancel that positivity out. So our answer to A is 6 electrons. Let's do B. What's the atomic number of carbon? Atomic number is the same thing as the number of protons. And we already have the number of protons. It is 6. So our answer to B is 6. C. Do some addition and find the atomic mass of carbon. The numbers that you add together here are protons and neutrons. So you have 6 protons and 6 neutrons, and that's going to give you 12 total atomic mass units. So C is 12 atomic mass units. The last part is D. We're going to draw the Bohr model, and I'm going to draw the Bohr model up top over here. So the most important part is that we need 6 electrons in those shells. C in the middle for carbon, and then let's get the first shell. It can only have 2 electrons, and we have 4 electrons left to draw. So second shell is going to have 4 electrons total. 1, 2, 3, 4. Make sure you don't pair them. And we are all the way finished with number 1. I will change to blue and let's try number 2. Nitrogen has 7 protons and 8 neutrons. Which has a higher electronegativity, carbon or nitrogen? Try it yourself. Well, carbon has 4 valence electrons, and we can see that in our Bohr model. There's 1, 2, 3, 4 in that outer shell. I'm going to write that down. Carbon equals 4 valence electrons. So it needs 4 more to finish out its shell. Nitrogen's a little different. We can draw the Bohr model of nitrogen quickly to figure out its valence electrons. And in the middle, first ring has 2 electrons, and then we have to get all the way up to 7. So 2, 3, 4, 5, 6, 7. So nitrogen has 5 valence electrons, and it's closer to filling that last shell. So nitrogen equals 5 valence electrons. Because it has more valence electrons and it's closer to filling out its shell, nitrogen is more electronegative. It wants those last electrons so bad. It just wants to be done. We are now finished with the review problems. Let's review some definitions and then get down to business. Some things you already know are the octet rule is the rule that atoms prefer to have a full outer shell. For the first shell, that's 2 electrons to be full up. For the second shell, that's 8 electrons. Once you hit 8, you are totally full of electrons in that shell and you actually can't take any more. So full second shells make elements into noble gases. They have 8 valence electrons and they are totally full. They just can't take any more. Valence electrons are all the electrons just in the outer shell. And those are the ones that are going to be interacting with other atoms and making chemical bonds. We'll learn more about chemical bonds later. Just know that the valence electrons, those are the ones putting in the work. Those are the action electrons. We learned about electronegativity, which is how much an atom wants to gain another electron. Why do they want electrons? Because of the octet rule. They want to fill that outer shell. The closer an atom is to 8, the higher its electronegativity, because it's thinking to itself, oh, I'm so close, if I could just have one more electron, just one more. Here's the kicker though, trick question. Is an atom electronegative if it has 8 electrons in its shell? Hear me out. If we draw an atom with a full first shell and a full second shell. Its second shell will have 8 electrons. Does it want any more? No, because that shell's already full. If it doesn't want any more electrons, it's not electronegative. So full outer shell, doesn't want more, isn't electronegative. So its electronegativity is actually like 0. This is so not electronegative. Today, we're going to be learning about elements and how to find them on the map that is the periodic table. An element is any pure substance containing just atoms with the same atomic number. So atomic number is the same thing as the number of protons. For example, the element carbon. If something's made of pure carbon, it's just made of atoms that have 6 protons each. If there are some atoms with 7 protons or 5 protons, those are actually other elements. We don't have pure carbon anymore. So remember that all members of one element are going to have the same number of protons. That's what defines an element. It's number of protons. The periodic table is a way that we organize elements based on their number of protons and electrons, and it helps us understand them. Today, we're going to work on reading this like a map so you can always find the element you're interested in. Elements are going to be labeled with letters. Sometimes it's just one letter, like carbon is C, nitrogen's N, potassium is K. Sometimes it's 2 letters though, don't get me wrong. We've got calcium, we've got nickel, we've got krypton, and those are all 2 letters long. The rule about this is if you got 2 letters, capitalize that first one, like the C in calcium, and the second letter can be lowercase, like the A in calcium. The best place to be looking at a periodic table for you guys is ptable.com. It is top notch. Always go there if you want to look at a periodic table while I ask you these questions. Always go there. Let's get started. Hydrogen has a special location on the periodic table, as does every single other element. You can define the location of an element based on its group number and its period number. I'm going to circle all the groups. They're up at the top. Here, all the members of group 1. It's this whole column is group 1. All the members of group 18 make up the noble gases on the other end. Now let's talk about periods. The periods are running down the side. You see that here. I'm going to highlight all the members of period 3. Those are all the members of period 3. So you can always use those 2 categories to find any element. As long as you have the group and the period, you have one unique element to look at. For example, hydrogen is in group 1, period 1. Let's try to find some more. Find the element that's in group 14, period 3. Find it yourself, and then I'll check it. Okay. Group 14 is this whole column, and period 3 is this whole row. So we want to go over until we hit group 14, down until we hit period 3, and you end up with silicon. Our final answer is silicon is in group 14, period 3. There's a neater way of us finding the answer, same answer. Let's do it again. Find the element that's in group 2, period 6. Try it yourself. Let's check it. Group 2 is everything in this column. Period 6 is everything in this row. So let's go over and down, and our final answer is barium. It's the only element in that spot, group 2, period 6. And there it is, a little bit neater for you one more time. We're going to try some practice problems. So let's start with A. Give me the group and period number of hydrogen. You got it if you said hydrogen is in group 1, period 1. Let's take down that answer. I'm going to say G1 for group 1, P1 for period 1. Do the same thing, but for nitrogen. Now let's check it. Nitrogen, if you look hard enough, is N. It's atomic number 7. It's in group 15 and period 2. Group 15, period 2. Let's write that one down. Group 15, period 2. Find the group and period of the element with atomic number 12. Atomic number 12. Let's check that one too. Atomic number 12 is going to give us magnesium. That 12 up there, remember, is its atomic number. What group is it in? Group 2. What period is it in? Period 3. So group 2, period 3 for magnesium, G2P3. We've got 4 more to do because I want to make sure that you guys are pros at this. Selenium. Let's check it. Selenium is all the way on the right over here. It's atomic number 34. It's in group 16. And on the left, you can see that it's in period 4. Group 16, period 4. Let's write that down. G16, P4, and barium. Try it. And we'll check it. Barium is down on the bottom left. It's in group 2, period 6. Group 2, period 6. Now find the element with the atomic symbol AR. And let's check it. Alrighty. If you look all the way on the right side of the table, AR is a noble gas called argon. It's in group 18, period 3. Group 18, period 3. Last one, bring us home. Al, atomic symbol Al. Find it? And let's check it. We're looking for aluminum, Al, atomic number 13. It's in group 13 and period 3. Group 13, period 3 is where aluminum and only aluminum lives. Group 13, period 3. G13P3. All right, I have one last thing to tell you before I set you free for today, and it's, why are we putting these elements in groups? Like, why are they in columns? What does that even mean? So every group shares something important. So hydrogen, lithium, sodium, potassium, all these bad boys here, they have something in common, and that's why they're grouped together. So this whole group shares similar chemical properties. So they're going to react in similar ways. The question is, okay, they're in a group because they're similar. Why are they similar? What makes them like that? Let's take a look at the elements that you might find in the same group. What you might find they have in common is that they have the same number of valence electrons. Let's count them. We have 1 valence electron, 1 valence electron in sodium, and 1 valence electron in potassium. So even though these elements have different total electrons, they have the same number of valence electrons. And remember what we said in the beginning of this video? That valence electrons, those are the action electrons. They're going to do all the work and dictate how that element's going to behave and react. So they have the same number of electrons that are actually busy doing stuff. What I want you to walk away today saying to yourself in your head is elements with the same number of valence electrons have the same chemical properties or similar chemical properties. And that is why they're grouped on the periodic table. You should write down what is underlined. So in group 1, every single element has a single valence electron. And in group 2, there are 2 valence electrons in every element. This pattern's going to keep going. Let's take it all the way to the end. Don't worry about the middle. We'll do that later. When you get to group 13, they all have 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5, 16 has 6, 17 has 7, and the noble gases, 18, have 8 valence electrons. And remember, that's why they are not electronegative. I just want y'all to double check that you have this written down. And then that is the end of the video. Thank you guys for working so hard with me. Please message me, email me, or come to the meet if I can do any practice problems with you.